right, greetings, YouTube. Beautiful mind here. I hope everyone is doing well on this lovely Friday, in spite of the social climate. I think it's been a full month, at least a full month that we've been quarantined. So I hope you're, this whole school thing can feel one way, but I think it actually helps to kind of cope. I don't know about you all, but it almost feels like the weekend doesn't exist anymore. It feels like every day is like Friday. It feels like the same day. I don't know if you ever seen this movie called Groundhog's Day, but that's what it feels like to me. Groundhog's Day is this movie. I think it's Bill Murray, where basically he just relives the same day, day in and day out, like for a long time, and that's what it feels like to me. But anyway, that's neither here nor there. The major announcements that we have for this week. So exam two has been up since about Tuesday. It is due this Saturday at 11:59 p.m. And then I think we just have our regular assignments. Okay. I'm available if you all have questions. Everyone should have full access to Pearson, and be sure to complete our participation and honesty quiz that is on Moodle. Okay. I don't know that we can actually submit grades without you doing that quiz. So you just want to be sure to get that submitted. Okay, so we want to watch the following presentation and take notes as if we're in class, and you'd have to write down your questions and reach out to me to get them answered. So today I'd like to continue chapter 3 and introduce this idea or this notion of what we call implicit differentiation. So in this chapter, has been devoted to calculating derivatives of the function y equals some f of x, where y is defined explicitly as a function of x, right? So we have y entirely in terms of x. However, relations between variables are often expressed implicitly. For example, the equation of the unit circle x squared plus y squared equals 1 does not specify y directly, but rather defines y implicitly. So this equation does not represent a single function because the graph fails the vertical line test. However, the equation x squared plus y squared equals 1 is solved for y, then two functions emerge. Y equals negative times the square root of 1 minus x squared, and y equals positive square root of 1 minus x squared. So having identified two explicit functions that describe the circle, we can find their derivatives using the chain rule. Okay. Let's see. So then, all right. So I'm going to do my implicit differentiation a little bit different than the way the book does it. It should work. I'm just going to do it until it doesn't work. So, like for instance, if we're looking at example 1, it asks us to find dy by dx directly from the equation of the unit circle. Let's see. So I'm just going to do it the way that I'm kind of comfortable doing it. Let's start by getting this like this. Okay. Oh, it's still too loud. Give me just a moment. Give me just a moment. All right, and we are back. So, I'm going to do it the way that I'm comfortable doing it, and then we'll kind of see the way that the text does it. And there's a couple of different techniques, at least that I'm aware of, that we can use to solve this. So let's start by getting a copy of the original. All right. So we have example 1A. Ooh, still too loud. So we're asked to find the derivative of y with respect to x of we have what? X squared plus y squared equals 1, right? So my favorite way of doing it is the following way. Okay, so the derivative of x squared, so here, let's write it here. We got x squared plus y squared equals 1. The derivative of x squared is, we're going to say 2x dx, plus the derivative of y squared is going to be 2y dy. And the derivative of a constant is 0. So then we just basically want to solve for, just get dy divided by dx, right? Let me think about this. Am I doing this fine? Let me keep going with this notion to see what happens. I feel like I'm missing something. Let's just keep going to see what happens. So then we're going to solve for dy by dx, right? So let's subtract the 2x dx. So then we get 2y dy equals a negative 2x dx. We can, what am I missing? I feel like I'm missing something. Because I think we just did this. Hang on. I might have to go back and do it that way. Let me think about it. Let me kind of keep going. Let me see. I feel like I'm missing something. Because then what I would do, you could divide both sides by dx, but I don't feel like this is right. Let me see what. Let me think about it. I got to think about it for a moment. So we get dy by dx equals, and this isn't right. Let me think about it. Why didn't this work? What am I missing? Let me look at it. I might have to go back and do it their way. Oh, it did work. Why do I don't know. Okay, so I don't know. For some reason, I guess I was feeling like it wasn't right. Let me see something. I think I was just thrown by the intro. Does not, the two functions emerge. We get this. If y equals this, dy by dx is this. We use equals 1 to find the slope. I don't know why I'm feeling like this is wrong, but I think it's right. Let me look at it again. Chain rule, that's fine. That's 0. That's fine. Negative x. This was a whole, provided that y is not 0 at this. The circle has vertical tangent lines. That's fine. I don't know why I get this thing like it should be different. I think the thing that I'm throwing is because in the intro, if we did the chain rule, okay, I'm not going to worry about it. So, but yeah, this is correct. So this is the way that I like to do it. And then part B, x is to find the slope of the unit circle at these points. Okay, what is that? If x, so 1, 2, 3, 1, 2, 3. What is it? 60 degrees. 1, 2, 3. And negative 60. Okay. So 30, 60, 90. I'm sorry, I'm just thinking out loud. Okay, so let's go ahead and answer part B and let's work another example. So example 1B, the x is to find the slope of the tangent line. Find the slope of the unit circle at 1 comma root 3 by 2. I mean 1/2. So we have 1/2 comma root 3 by 2, and we want to do 1/2 comma negative root 3 by 2. Okay. Let's add a page and keep going. Let's see. So we have that dy by dx is negative x by y. Let's see the proper way to write it at this point, right? Okay. So then we want the slope, or dy by dx, when x is 1/2 comma root 3 by 2. So basically when x is a half, that's going to give us negative 1/2 over root 3 by 2. So then we get a negative root 3 by 3. Okay. And then dy by dx when x is 1/2 comma negative root 3 by 2. That's going to be negative 1/2 divided by negative root 3 by 2. So it's going to be positive root 3 by 3. So we got these two results. Okay. So I think that was like the 30, 60, 90 triangle, right? Is that all that we did there? So let's shrink this down to one page. Okay. Okay. So you see over here on the left on this image here, what's going on. So we have the unit circle. At the point 1/2 positive root 3, the slope is a negative 1 over root 3, which is the negative root 3 by 3 we got. Has a negative slope, but then on the right hand side it has a positive slope. So rise over run, right? Okay. All right. Let's go like this. Let's see. So example 1 illustrates the technique of implicit differentiation. It is done without solving for y, and it produces dy by dx. Let's see how do they do it. So I just want to kind of take a look at the way the text does it, right? So they replaced y with y of x, okay? And then we take the derivative of each term with respect to x. So the first term, x squared, the derivative of x squared with respect to x is just going to be 2x. But here we need to use a chain rule. So the derivative of the outside function times the derivative of the inside function. You see it here. So y squared is going to become 2y of x times y prime. So then that y prime is our dy by dx. We solve for dy by dx, and we get the same result that we have. So, I mean, and that's fine. I forget the name of the terms that I'm using. I know if we're talking like economics, that'll be like marginal cost. But the dy and the dx, I forget the name. But that was the way that was simplest for solving those for me when I was learning this. Just find the dy, find the dx, and then try to solve for dy by dx. It didn't always work, but it got me through most of it. That was the way that I preferred. The other one, I struggled to keep track of it. Let's try another one though. So in example 2, we're asked to find y prime when we have sine of x times y equals x squared plus y. Okay. So with this one, the original we have is, so this is example 2. What is squeaking? All right. We're asked to find y prime of x, which is essentially dy by dx. Oh, dy by dx of, we have sine of x times y equals x squared plus y. Okay, let's give it a go. So if we have sine of xy equals x squared plus y, think about this. Okay. So then to take the derivative, now the derivative of sine, we're going the first part on the left, we're going to have to use the chain rule. Derivative of sine is what? So that's going to be cosine of x times y. That's the derivative of the outside function. And the inside, on the inside, we're going to have to use the product rule. So I'm going to write it like this. So we have the first thing times the derivative of the second. The derivative of y is just going to be dy. The first times the derivative of the second plus the second times the derivative of the first is dx. Okay, we'll get this. So that's the entire left. We used the chain rule and the product rule. So it was two different rules in once. And then on the right, the derivative of x squared is going to be 2x dx. And the derivative of y, again, is just dy. So then now, what's a good idea? We're gonna go ahead and distribute this cosine x times y. And then we're going to get all our dy's on the left, all our dx's on the right, and then we should be able to get the dy by dx. Okay, so if we distribute, let's see, I'm going to write it in the following way. We're going to have x cosine of xy dy plus y cosine of xy dx equals, and then I think the right hand side just comes out 2x dx plus dy. All right. So now let's get all the terms that have dy on the left. Let me see our dy. There's a dy here, and there's a dy here. Instead of yellow, I'm going to do orange because I feel like it pops a little bit better than yellow. And now dx, we'll do this one. Got Goku colors going today. Okay. So if we move the dy's to the left, we're going to have x cosine of xy dy minus the dy from the right. We're going to say equals, if we move that y cosine xy to the right, we're going to have minus y cosine xy dx plus 2x dx. Okay. There's a dy and dy. We got this guy and this guy. Okay. So now let's factor out the dy. So then on the left, we're going to get dy times, we're going to have x cosine of xy minus 1 equals dx. I'm going to rewrite it as 2x minus y cosine of xy. Okay. I feel like this is okay. So now we can divide both sides by dx, divide both sides by that term next to the dy, and we should have our desired result. So now we're going to have dy by dx is going to be equal to 2x minus y cosine of xy divided by x cosine of xy minus 1. Okay. So then the dy's and the dx. All right. Let's see. Can anything cancel or factor? I think this is it. So I don't see anything that can cancel or that we can factor. Okay. Now let's compare this to what the text has. and we see it here, right here. So then y prime is 2x minus y cosine of xy divided by x cosine xy minus 1. That was fun. This was always my favorite. Like, because like when you get it, like, I don't know, initially it seems intimidating, but when you find, like, when you figure it out, it's just so rewarding. And I mean, it has so many like applications. Like we use it. We actually use this stuff and we're just not aware of it. This is like the language of the underlying structure of all these different processes that are going on all around us that we're just totally not aware of. But okay. So notice that y prime is in terms of both x and y. All right. So slopes of tangent line, let's see. So let's do this really quickly because that's kind of irking me. Oops. Let's copy and paste. That's fine. Let me see. Find an equation of the tangent line to this curve at the point 3, 2. Okay, we can do this. So let's go paper. Let's get that grid paper going. So the original, so we want the slope of the tangent line to the curve. We have x squared plus xy minus y cubed equals 7 at the point 3, 2. Remember, the derivative is going to give us a slope of the tangent line at a point, and then we can use that slope to find the equation of the line. All right. So let's find our dy by dx. So the derivative of x squared is going to be 2x dx. X times y, we got to use the product rule there. So the first times the derivative of the second plus the second times the derivative of the first. That's it. We're done. And then the next one is the derivative of y cubed is going to be 3y squared dy. The derivative of a constant is 0. So now let's get all our dy's on the left, dx's on the right. So let me see here. Here's one dy, and here's another dy style. And we got a dx here and a dx here style. Okay. So then on the left, we're going to have x dy minus 3y squared dy equals, if we move those dx's to the right, we're going to have a negative, that's fine, 2x dx plus y dx. Okay. Here's this guy and this one. These two are this style is this. Oh, I see a mistake. Minus and minus. I thought so. Let's get rid of this. Oops. Undo. We want this and like that. Boom. So both of those are negative. That's fine. This looks good. So then we can factor out, right? Factor out the dy. So we have dy. We're going to have x minus 3y squared equals, factor out the dx. We got a negative 2x minus y. Just for the sake of not having so many negatives, I'm going to multiply the left and the right. I'm going to distribute a negative into all the terms on the left and the right. So on the left, we're going to have dy is going to be 3y squared minus x. On the right, we're going to have dx is going to be 2x plus y. Okay. So then now our dy by dx is going to be divide and divide. We got this 2x plus y divided by 3y squared minus x. So we get this. Okay, let's see, how do we do? Oh, wait. That's just the slope. That's just the equation. So let's go back and answer the question. So we need to find the equation of the line. So this will give us a slope, and we want at the point 3, 2. So we want at the point 3, 2. So then we're going to have dy by dx at the point 3, 2 So when x is 3 and y is 2, so 3 times, so it's going to be 2 times 3 plus 2 divided by, what was that supposed to be, 3y squared? Oh, did I lose my y down below? Yeah, I sure did. Let's just move you up a little bit. There it is. Okay. It's going to be 3 times 2 squared minus 3. Okay. 6 plus 2 is 8 divided by 4 times 3 is 12 minus 3 is 9. So that's going to be our slope. So then I prefer this way. Y, if we're going to use y equals mx plus b, so then our y is 2, our m is 8 by 9, our x is 3. Only thing we don't know is b. This turns this into a 3. So if we subtract 6 over 3 minus 8 over 3 equals b, so then b equals a negative 2 by 3. Okay, so then ultimately we're going to get y equals the slope 8 over 9x minus 2 by 3. So this should be the equation of the line. Now we can actually check this before we look at the answer. Let's look and see how we could check something of this nature. So I'm gonna use my Texas Instrument. Let me go ahead and get it ready first. Come on. There it is. That looks good. Let's reload and refresh. Okay. So suppose we wanted to check something like this before, we just wanted to check, right? We see the original at the top with our solution. So, oh, wait a minute. I might need my 89 for this one. Because we can't get, I don't think I can get this one explicitly in terms of y. I think there is a way to do it. I know I could do it on my TI-89. I'm not sure about this one, and I'm not going to take the time to figure it out. I think on the TI-89 we could actually check this one. But, we just have to kind of do the best that we can. All right. So we got y equals 8 over 9x minus 2 by 3. Let's see, how do we do? Yeah, there it is. 8 over 9x minus 2 by 3. Okay. All right. So yeah, that's correct. Let's see, example 4, it says, find the slope of the curve. So basically just find the derivative at that point. Okay. Let's see, so the original, we have 2 times x plus y to the power of a third equals y. At the point 4 comma 4, we want to find dy by dx. Okay. So let me work down here on this next page. So the original we have is 2 times x plus y to the power of a third equals y. So if we want to find dy by dx, on the left-hand side, we're going to have to use the chain rule. So if we use the chain rule, the derivative of the outside function times the derivative of the inside function. The outside function, that 1/3 comes down. So we're going to have 2 by 3 times this. 1/3 minus 1 is going to be a negative 2/3. Okay. That's the derivative of the outside function times the derivative of the inside function. The derivative of the x is going to be dx. Derivative of y is going to be dy. And then on the right, the derivative of y is dy. Okay. So then let's distribute this and do the same technique that we've been doing all day. Okay. So then we're going to have 2/3 x plus y to the negative 2/3 dx plus 2/3 x plus y to the negative 2/3 dy equals dy. So I want to get my dy's on the left and my dx's on the right. So we're going to have this 2/3 x plus y to the negative 2/3 dy minus dy equals, actually, just to minimize my negatives, what I'm going to do, I'm going to move the dy to the right, right? So we have this 2/3 x plus y, I don't know what that was, x plus y to the negative 2/3 dx equals, we're going to say dy minus 2/3 x plus y to the negative 2/3 dy, okay? So now if we factor, I'm just going to flip the equations because I just going to work with my dy on the left. It's going to be the exact same thing. We're going to have dy times 1 minus 2/3 x plus y to the negative 2/3. Okay. And that's going to equal 2/3. Let's see. X plus y to the negative 2/3 dx. All right. So I'm going to basically divide by dx and divide by the term on the left. So we're going to get dy by dx equals, now on the right, let's see. We're going to do some simplifying. So let's just go ahead and write it first. 2/3 x plus y to the negative 2/3 over 1 minus 2/3 x plus y to the negative 2/3. Okay, we just need to clean this up. Let's go ahead and add some more paper. Okay. Figure out. All right. Let's see. Let's start by multiplying top and bottom by 3, right? Let's do this first, just to kind of clean up these numbers a little bit. So then on top, these are going to cancel. We're going to be left with 2 times x plus y to the negative 2/3. On bottom, if we distribute 3, we're going to get 3 minus 2 x plus y to the negative 2/3. Okay. Let's see. So keep in mind that negative exponent are fractions. So we want to rationalize. We're going to rationalize. I'm going to multiply the top and the bottom by, let me think about it. If that was a positive 2/3. Okay. I'm going to multiply by 1 in the form of x plus y to the power of 2/3. Okay, I'm just doing this to see what happens. Okay, I'm going to multiply by 1 in this form. Okay, now on top, we're multiplying exponents at the same base. So if we add those exponents, they add up to what? 0. So that becomes a 1. So that becomes just 2 on top, right? I think that's the whole point. I think that's how that goes. So it looks like this is going to cancel this, and I think we're okay. That one's going to cancel one of. We will have one persist, which is fine. I just felt like we didn't need so many of those. Let me see. So if this is going to be gone for the same reason, it looks like we're going to finish with 3 times x plus y to the 2/3 minus 2 under 2. we're going to say dy by dx. Let's go back and answer the question. At the point 4 comma 4. All right, I'm going to stand with this answer. So then we're going to find dy by dx at the point 4 comma 4. All right. So when x is 4, y is 4. So then what we're going to get is 3 times 8 to the power of 2/3 minus 2 under 2. Let's see what we get, what happens. So the cube root of 8 is 2. 2 squared is 4. Okay, 4 times 3 is 12 minus 2 under 2. That's a 10. So 1 by 5. So we get a slope of 1 by 5. What an adventure. Let's go like this. All right, come on. There we go. All right, let's see how do we do. We got an answer of 1 by 5. Okay. Was that it for that one? Okay, let's see. There it is right there. What an adventure. That was an adventure. See it here, see it here. Do a little dance. Make a little love. Get down tonight. I'm gonna do this real quick. That was fun. I don't know about you guys, but that was fun. Again, it looks intimidating, but you just gotta do your best, right? You know, there's a lot at play right now, and you know, I know it is what it is. Just do your best, and it'll be okay. Like honestly, it'll be okay either way. Okay. Can you go away notification? Thank you. Let me. I need to put this thing on the charger before it dies. What is this? I'm not using that right now. Where's my other cord? I'm using that one over here, so I can use this one. Ooh, good job. All right. So I think we have like one more. Where did my pen go? Here we go. All right. So a second derivative. Find the second derivative of y with respect to x if x squared plus y squared equals 1. I think that's all that it's asking. Okay. So we're asked to find basically the second derivative. We got the second derivative of y with respect to x if we're going to say find x squared plus y squared equals 1, right? Okay, so basically take the derivative twice. So first we're going to find dy by dx. And let's go ahead and add a page. Okay. So first we're going to find dy by dx. So a derivative. So if the original is x squared plus y squared equals 1, then we're going to have 2x dx plus 2y dy equals 1. If we subtract and divide, let's just write it out. 2y dy, up, and derivative of constant is 0, equals a negative 2x dx. So then ultimately, dy by dx is going to be negative x by y, right? So then we take the derivative again. Let me think about it. Okay. You know, I never thought about how to do that implicitly, the way I've been doing it. I mean, I get you just take the derivative and it makes sense to me. Let me think about it. Give me just a moment. I don't want to make something up. What if we said the bottom? Do we need to do that here? Well, just for the sake of simplicity, since we already have dy by dx by itself, this is already y prime, I'm going to do the following. So the second derivative of y with respect to x. So now we just use the quotient rule. The bottom times the derivative of the top. So low d high minus high d low over low low. So the bottom times the derivative of the top, the derivative of, hang on. I want to be consistent in my technique. Let me kind of glance. Let me just go ahead and finish out and do what I originally was going to do. So the bottom times the derivative of the top, derivative of x is what, negative dx? Bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Okay. Let's be consistent. I don't know why I'm hesitating. Let's be consistent and do the same thing, right? So let's do the quotient rule on the left as well. We're going to say the bottom, which is just going to be dx, times the derivative of the top. The derivative of dy is going to be, that one is going to be, let me see. We're going to say, I'm just going to do d squared y, the second derivative with respect to y. So that's the bottom times the derivative of the top minus the top times the derivative of the bottom is going to be dx squared. It's just, it's the second derivative. I think I'm doing this right. Over the bottom squared. I feel like I'm missing something, and I'm not really sure what it is. Let me look at it. I'm confusing myself there. Let me look at the result. So d by dx of that. That's fine. All right. D by dx of that. So on the left, we should have that. And on the right, okay. So what I had originally was better. So let's go back to this thing. Delete. So if we take d by dx of that, on the left, we're going to have, d squared y by dx squared. On the right, we have this. Let's see. Because we could distribute. Let me see, what else am I missing? So we got the dx. We got that. Let's see. Oh, dy by dx. I see. Okay, can we get that in hours? Okay. Okay, so instead of doing it this way, I don't want to abandon it. Hang on. Bottom times the derivative of the top. How can we be consistent? Bottom times the derivative of the top. Top times the derivative of the bottom. Because once we have the dy by dx, then we can plug in. Let me see. Oh, okay. So let's do this instead. It keeps popping up. What am I missing? Oh, we can multiply by 1 over x, 1 over dx. Does that help us? Because we get it there, but then we don't have it there. Let's see. Take the derivative with respect to x. That's fine. I'm still trying to do it the way that I've been doing it, but let me multiply by 1 over x. All right. Well, I was trying to avoid it, but okay. So another way that we could do it, I'll just kind of use what the book is doing. If we take the derivative with respect to x, so the derivative of negative x is just going to be -1, right? So this is -1. We see bottom times the derivative of the top minus the top times the derivative of the bottom. The derivative of y with respect to x, instead of dy, we're going to write that as dy by dx. Dy by dx. I had to go and think about it, how to do it consistently the way that I was already doing, unless I did like maybe a second equation. So we're going to let me try that second equation technique, like substitution. So say the dy by dx is this. Now, yeah, let me just put a star. I'm going to put a star in this because for some reason I just couldn't let go of the technique I was using. You can follow along what the book is doing from that line. I want to kind of keep going with my original train of thought. So what I'm going to do, I'm going to do substitution, and I'm going to let me think about this. This is another function. Can I do a second function? I guess I'm going to let it go. Because like if I did like a function g, but then this kind of feels like it's introducing another variable. I'm missing something, so I'm going to let that be. I'll just go ahead with what the book is doing for right now. Okay, so now that we have the dy by dx, we can substitute in what we just found, right? I know there's a little bit kind of like this, but then we're going to get a negative y. Double negative is plus x times negative x by y over y squared. Again, this is d squared y by dx squared, okay? So then, dog, what do you want? You were just outside. No, get down. No. So then let's see. If we keep going, let's distribute. We just need to simplify this down. So we're going to have negative y. That's going to be minus x squared by y over y squared. Let's multiply the top and the bottom by y. We're going to multiply by 1 in the form of y over y. Okay. And if we distribute this, we're going to get negative y squared minus x squared over y cubed. What did the question ask us to do originally? Second derivative. I feel like I have a lot of negatives. I can't see anything else. Negative y squared minus x squared by y by 3. Oh, and then from the original. Okay, I see. So from the original, we had that what? X squared plus y squared equals 1. So then that top just becomes negative 1 by y cubed. Yeah, that one wasn't as smooth as I would have liked. In the last step, we used the original. That's fine. I might have to look up implicit differentiation of higher order, like second and third derivatives using implicit differentiation. Is this working now? Nope, still not working. All right, well, that's how it goes sometimes. Style. All right, so we'll get this. And that's the second derivative. That's the second derivative of y with respect to x. Okay. That one was fine. So this. Bottom times the derivative of the top. Bottom, yeah, okay. Bottom times the derivative of the top minus the top times the derivative of the bottom. Yeah, I was just trying to see something, but I'm not seeing it, so I'm gonna let it go. I had to kind of do a quick search or whatever. Okay, so but so we are using Pearson. Pearson, we have we have explanations associated with each question. Okay, ooh. And make use of the Ask My Instructor on Pearson. Okay, so I'm here. We also have tutors there. You have a lot of support. You have people that can help you. Don't feel like you're in this alone. We're gonna kind of let that be for now, and we're gonna actually end the session here. And from one beautiful mind to another, enjoy the rest of your day. Peace.